Hello students, welcome to EduCell. In this video, we are going to discuss about center selection problem, which is a part of approximation algorithm. And I'm requesting you, those who are new to this video, kindly watch the previous videos related to this approximation algorithm. And one more thing I'm requesting you to watch, which is triangle inequality, which is there in approximation traveling salesman problem. You just watch that one, then you come for knowing exactly how center selection is working. Okay. Before going to depth towards this content, I must tell you, like, I'm following the book which is written by Eva Tardos and Klenberg. So that is also I have kept in the resources of this description of videos. You can check that out. What exactly the center selection then? Whenever we are trying to give basically you can say the proper example would be like I have seen the book. So here they have taken the example of malls, okay, or might be mall you can think. So I kept the content this side. You can say whichever, suppose there is a within a given town or might be within a given city, there are different locations. Okay, based on the locations we must say based on a strength of population we should have to uh, build a mall. Okay, like a mall will be built, like you can say the we will build a mall based on the strength of populations, because we cannot say basically how many people will come to might we get might we go for the shopping, or we cannot even if say like within just 100 of people are there in just area, so I'll build a mall. This is just a you can say we cannot make profit out of it. Clear? So to make profit out of it, we will select those locations where most of the populations or nearby population are high. Okay. In that case, whenever we are selecting, like you can say there are within a city or a town, there are different locations where the population based on the strength of the population, there are we have certain divided in the different points. In a real life, I must tell you, like we are just segregating that in a map as longitude and latitude. Okay, as well as if I consider in the mathematics point of view, like you can say these are x1 x2 as well axis, like you can say the coordinate of it. So based on that, whenever we say the Euclidean distance, you can say the Euclidean distance that you have already read, like once you are finding out between the distance of two different points as x1 x2 with a sorry x1 y1 x2 y2, the distance that you have already studied, like d is, suppose you are keeping distance as d, then it is the root over x2 minus x1 square plus y2 minus y1 square, that you have already read. So whenever we are discussing on a plane, so that is we are just considering on a Euclidean distance between those points will be fine. Okay. Next, whenever we are setting off a mall, okay, so we should have to know where we should situate, like the people will come, the distance should be less. That is what our motto is. Clear? So here they have clearly mentioned the closest mall. Basically, the malls where we are going to situate, that should be close enough where we will maximize our profit. To build a less number of malls, we will maximize the profit. Suppose you are a builder, you are thinking for the mall, and your target is, suppose Bhubaneswar is your target, or might be any city you can pick, okay, as a best city for your choice. Suppose you are planning for going to have 2 3 malls and you try to maximize the profit. So which one to be fixed or which one to be find it out are the proper locations for the mall. That is why you are finding the center, uh, you know where you can establish your mall. This is why we are trying to read our center selection problem, like which one to be selected as our center of point. Clear? This is what our target is. Now after clearing this one, so I must tell you certain mathematical you can say conventions which are to be used. That is k is a set of integers, or suppose you can say k is set you can say set of centers, where c is a k is the centers, you can say, which are to be selected, okay, which are already you have fixed it. And C is set of centers. I am writing it, set of centers. K is the centers that we decided as it's just an integer for us. Next, C star, as we have already read on earlier videos, like definitely it is optimized centers or optimal centers. Okay, optimal set centers. Don't worry, we will discuss about exactly how we will find it out. And S, you can say set of cities, sites. As for the book, it is written as sites. Okay, you can say locations also. Clear? So these are the prerequisites we should know. Next, we will be reading exactly what it is written. Clear? So I'm just reading one by one line, and I'm just telling you like why it is written, how we will exactly get through this content. Okay. So we are giving k integers where I said like it is just centers for us. Clear? A set of s n sites. That means we will have certain locations which is might be up to n. N means anything. Okay, like from 1 to certain countable things, because here we are just focusing on the real time scenario. So there is no such unlimited kind of things or unlimited kind of stuffs to be added. Clear? So n number of sites there within that. So where corresponding to this town, like whenever we are focusing on a city, there are different locations. So we are just keeping those as a set of our locations. Okay. And the distance function. Distance functions mean between them, we should have to know like what are the distance between those locations. Why? Because we need to establish one mall. Okay, the mall will have to at least less distance to the locations, nearby locations through which we will expect the people will come, and we will enhance our profit, or we will make more profit out of it, because this is what our target is now. If you establish a mall between might be the locations, there are 4 5 locations where the strength of people is more, and you're just in mid of those locations, definitely people will reach out from the nearby locations. The more the people will come, definitely the more the profit you can gain. Okay, this is what in general concept we are having. That's why we are finding out the center. Next is, so whenever we decided that one, what to be done, like we have to then we consider the instances. This the distance has to be find it out. The application, whenever we are coming to the applications, how to measure the distance, there are three different categories that you have already read it. One, suppose you are finding the distance between two different sites, like the small s represents the small s. This is a capital S. Clear? The small s represent one site. Okay, one site, or you can say one location out of the set of sets, or out of the set of locations. This is one site or one locations. So what exactly we have to do? Suppose we are finding the distance of the same position. We know we have already read in the mathematics, there it is 0. Clear? Where it is written for all s, small s represent one site out of the set of sites. Next, the distance, whenever we are saying the symmetricity or symmetric basically, so there we should know like if there is another point which is named as z or z, you can say, so the distance between them should be equal. Okay, because we have already said like the Euclidean distance, it should have to follow. Clear? Next, triangle inequality. For triangle inequality, basically whenever we are focusing on like the better example would be, suppose we are picking which distance. Suppose here is A is connected to B, next there is C, and again B is there. Clear? So suppose we are getting a direct connections from A to B, I want to move. Here is our source, here is our destination. Suppose I want to move from 1 to B. There are two approaches. Either from A to B there is a direct one, another A to C, C to B. Clear? So here the same thing with a different naming convention, S to Z, okay, and S Z to H. If you can say, I'm just changing the name accordingly, which will be better for you to understand. Small s, then H, then Z. So through that, whichever is lesser value, we will pick that one. Clear? So it's a triangular inequality means, okay. Like here the distance from S to Z, this one, next from this one, if you're getting higher value than this one, so we will pick S to H. This is for the triangle inequality. So that's why I told you like triangle inequality will helpful for this one. So that's why you just watch the previous videos. There is a video named as approximation TSP. Clear? Next thing is, whenever we are finding out the center of it or center point of it, what exactly we are, how to find the distance. We define the distance a site is to centers. Basically, whenever we set a center, we selected a center, then the distance could be found out. How? Like the minimum of the distance between the centers to the site which we have selected. Clear? This is what it is written. The centers of set C, small c, is one center. One center. Clear? Small c is one center, capital C is set of centers. Clear? So it is clearly mentioned that we will keep the distance of the selected site to all the set of centers. Which one we will keep? The minimum one, which is the nearest center of all the set of centers, will be picked as the distance. Clear? So what exactly we should say in other way? It is clearly mentioned. We say that the C forms an R cover if each site within the distance at most R form one of the centers that is distance, which is we have recently discussed the distance. If it is, we have said it is a lesser value, we say this is our R cover. Okay, just naming conventions. I just want to tell you that naming conventions within that, suppose a distance which is fixed as R, means the radius basically we will be focusing on. While we are focusing the radius also, I'll tell you that one also. So how we will be saying the distance? It is should be less than R. Okay, so the minimum R which C an R cover will be called as covering radius of C and will be denoted by RC. Okay, this RC we should know. The RC represents the basically the radius which we are focusing on, that should be denoted as RC then. Okay, so in other word, the covering radius of the set of C farthest that anyone needs to travel to go his or her nearest center, which I told you earlier. Our goal, basically, what is our goal? Here it is written. Our goal will be select set of centers, okay, of K centers. Like I told you, K is a centers, by the way, which is RC as the smallest possible, means the radius should be smallest one. Like whenever we select the centers, the nearby locations which are there, that should have at least less distance. This is our target. Once we'll know the target, then we can understand better on this. Okay, so I hope it is clear. Next, why we are focusing with the centers? Clear? So you just think there are different cities, within a city there are different locations. If I would like to say, like, I just want to tell the nearby locations. So nearby locations, we should have to say, suppose radius, then we will be fixing off with a circle. Once we will fixing with the circle, there are many such locations will be within this area. That's why we are keeping this a circle. So those who know networking, computer networks, there whenever we are establishing the mobile tower. Even if we are focusing on a Wi-Fi access point, that time we are also focusing on the range as oval circle, or sometimes we are just keeping in a hexagonal way. This says our coverage. So that is why whenever we are focusing on a mall, as we said, this is our center, so we should know our coverage. So coverage, if you are trying to find it out, so you should have to follow the circle. So though you are following the circle, that's why you are trying to find out the radius of it. Okay, so I hope you understood that one. Now we will focus on the designing part of this analysis, the design and analyzing the algorithm. Like once we have to set a problem, then we will go for the solution steps. Okay. So I kept this content, but we should have to follow only this part. Okay, that part is also you can read whenever you are getting time. So in general, like the people are not reading the book well, that's why I'm keeping the page of those books through which you can easily understand how and why it is written clear. Next thing is, so here they have like the authors have thought like two cities S and Z they kept, where K represents 2. That means there are two different locations we have, and K represents as 2 means, so we can set up two different centers, two different malls with two different locations. Two different locations are like S and Z. There are two different locations. K is you can say the number of malls how many we can build. Like we have money, suppose I have 2 crores, I have to spend 1 crore each, means I can at least spend one which is 2 malls I can build in two different cities, clear? Or might be one mall if you can do that one. So can it be for S and Z? So that we are going to discuss now. So next, assume S and Z are located in plane, distance equal to the standard Euclidean distance. The standard Euclidean distance at which we have discussed earlier as x2 minus x1 square plus y2 minus y1 square whole root of that we have already discussed. On a plane, basically we have to keep that one. Whenever we are focusing on the distance between S and Z, whenever we found out, like we found out from the Euclidean distance. Next, suppose I want to find the best location, like I want to place one single mall. So whenever I am placing a single mall between S and Z, what I thought I will be keeping a midpoint which is named as C1, where I'll expect the distance. Suppose this is D, the distance is D. So I must tell you the distance from this end and the distance from this end will be d by 2 and d by 2. Clear? Suppose I am doing that one. So I am just keeping one mall in between them. So it is clearly mentioned the best location for a single center C1. Suppose I am just keeping it the halfway between S and Z. Like I can place one mall and I can treat both the locations within my range. Clear? So next, the covering radius. Whenever we are finding the covering radius of this one, the center is R of C1. Whenever we say R of C, that represents what? It is clearly being mentioned here. Clear? R of C1, like the radius of C1 means the distance between the two different points are considered as a d by 2. Clear? The distance will be half of it. Because we are keeping in a midway up to two different locations. So the greedy algorithm would start with C1 as a first center. As we said, like we have to use a greedy approach through which at least we should have to provide a mall with among the cities, or sorry, among the locations within a city. Clear? So what it does, like no matter wherever we add a second center, suppose we said K has to be 2, means we should place two different malls. So here we will not focusing on within, if K is 1, we will happy with it. No. If K is 2 means you have to set up two malls. Okay. So in this case, what exactly greedy does? Greedy just giving you the better solution with having a C1 in the mid of this one. Clear? So that is what it is written, like second, if we add a second center, at least one of S or Z will have the center C1 as closest. Okay, and so covering radius of set of two centers still D2. So note that the optimum solution for K2 is select S and Z themselves as a center. Suppose I am saying the optimal one. This is what our approximation. Clear? Whenever I'm just saying you for K2, whenever I'm focusing on optimal, so S will be considered as a center and Z will be considered as a center. Then only we can say this is our optimal result, because K is 2. So here K is 1. Within K is 1 we have set our radius, everything. But here if we have to focus with the K is 2, then two different malls we have to definitely build, and why not to follow this two different locations. This is what it says. Clear? So optimal, and somehow whenever we are focusing on this greedy, there we are finding out some problems which we have already covered in the previous videos too. Clear? So next, the second content which I have kept here, as for the like why we are keeping the radius r as r2, that we are going to discuss it here. So this C star that I told you, that optimal values where C star, small c star is the center of the bigger C star. Okay, this bigger C star is a set of optimal centers. You can say here the optimal center is C star. It is also written there. C star belongs to capital C star, means the small C star is a center within a small center, or the one center of the set of centers, the set of optimal centers basically. Okay. So whenever we set this S, S is a you can say one of the site belongs to a capital S. Okay, so here it is written as this one. A small s means one of the site we are picking from all the sets. Sets means there are 1, 2, 3, 4, 5, 6, 7, 8. So we should consider the center also as a site of it. Clear? Based on that, we are just keeping one of them, and how to find which is the perfect radius for our covering all the uh, locations. Whenever we find it out, what we do, like here we said it is r distance. Okay, this is r distance, here this is r distance, here this is r distance, or less than r. Okay, r or less than equal to r, because we have already discussed for our optimal case the distance should be less than equivalent to r. So I'm just saying that is equivalent to r. Whenever I'm saying s small s, which is covered by C star, if I want to say it is no, it should be my center. Whenever I am saying it should be the center now. Whenever I am saying it should be our center, in this case what it has to do, like we will be applying the triangular inequality. Okay, so the triangular inequality case, whenever I am applying here, I'm just changing the color now. For this case, triangle inequality, through triangle inequality we will select 2r instead of 1r. So we will select 2r, through which at least the radius will be the range of this one to 2r. This is our 2r now. Clear? Whenever we have the radius using triangular inequality, we have to fix this as 2r. How? Like this is suppose u to v, as we have already discussed u to v, even if we are just finding the minimum one, so that we found out at least 2r is giving the minimum result than the suppose any point within that locations, which is a triangular inequality or triangle inequality means. Okay, through that we set, instead of getting r, we should have to take 2r, through which at least we will cover all the points, because s is a part of optimal. Okay, So if we want to cover all this, which is a part of optimal, we thought, can we get all the values within this as optimal or not? That's why approximation is what? Towards optimal, but not equivalent to optimal. Towards optimal. Basically, that's we are doing it here. That is why it is clearly mentioned all the sites, all the sites that are the distance at most r with center C star are the distance most 2r from S. Like if we said S is a new center for us, then so we should say 2r is our 2r is our radius now. Okay, based on that, one algorithm is there in the book. It is clearly mentioned. So S prime is equivalent to S, which is set of sites or locations. Okay, this is what we have to first keep in mind. Next is I'll be giving you the example also. I'm just saying the example could be here 1, here is B, that is C, I'm just writing it here, D, E, F, G. Okay, for the example, through the example we will understand this. G, then H. For H also I'll be considering this one. Okay, so where initialize, like whenever we set S dash is now equivalent to S, which is set of locations. The set of locations are A, B, C, D, E, F, G and H. These are the locations which we have selected. Okay, next is let C. C is a set of centers. C is a set of centers. Initially it is 5. Initially it is nothing now. Clear? We will run while condition. Clear? What while condition says? Until it is empty, what we have to do, we will select any site. Means randomly we will select any site and add S to C. We will add that S whenever we have selected any of them, we will add that in our center. Clear? Next, delete all the sites from S dash or S prime that are a distance most r to at most r 2r. Basically, whenever we say like 2 times r, within that at least we will be deleting that one. Now we will decide how to find the center. We don't know what the r exactly here. Okay, so I'm just writing, suppose it is r 2r. Within this range for A it is 2r now. Clear? Suppose and here also I have to keep the value of k. Without that, the value of k it is not yet mentioned. I'm just saying we will be keeping 3. 3 moles could be established. Clear? So I'm just selecting A as a center. Now what do I do? I have to place here A. Whenever I'm placing A, within that range B is there. Clear? So I have to cut that B. Then I have to select randomly. I'm picking one. Okay, so whenever I'm picking G, maximum selection you can expect up to this, which is like the circle should be proper. Okay, otherwise there will be a problem. So suppose think this is our for G. Clear? So what we have to do is, like you can say Up to this we say this is our 2r. Clear. Next within that we have b, we have e, and we have, somehow we have to keep h because it is within the range of it. Just think. Okay, so when I am keeping g, now what I have to remove, because here it is said as delete e and h. B is already being deleted. Now I have to keep at least one more, because it's not exactly being mentioned one more or two more. So it is clearly mentioned until you are reaching with a deletion of everything. Okay, so you can see if I'm picking D as a 2 radius. So suppose think you, this is our 2 radius, 2r. Okay, so next I'm just putting D. When I'm putting D, so I have to clear. This is what we have to do. Next, until it is empty, it is clearly mentioned. So nothing is there. If I am saying the 2r is like this, 2r, we cannot delete anything and we are simply writing this one. Clear. Whenever it is done, we will be having to check whether c, this bar represents the scalar value of c is less than equivalent to k or not. Here c is 4 and k is 3. Clear. 4 is not less than 3. So what we have to do? So we have to run the else condition. Clear. 4 is not less than 3. So that's why we are running the else conditions. That there is no set of k centers with covering radius at most r. We cannot guarantee them if such things happened. But this is not always correct. In some cases, it might happen, it might not be happened. Clear? So we have to just think of with the algorithm. This is one of the algorithm of which is following greedy approach. The next algorithm which we found, no, this is not correct. So what we have to change then? We have to change is here the assumption which we set is suppose k is 3. The same example I am taking. K is 3. Definitely S mod which we have taken as 1, 2, 3, 4, 5, 6, 7, 8. So S was 8. Clear? This is our assumptions. So we should know whenever we are picking up the mod, that should be at least equivalent to 8 or less than 8. This should be at least being assumed. Clear? Otherwise, we have to define all as our centers, like all the selected, all the sites or all the locations as our different moles for us. Okay, else part. Next, select any site. Okay, any site we have to select. As we have selected any site, so we will consider that one of the center for us. What they have changed, instead of keeping the S dash or S prime to be empty, so there they have considered as, this one is considered as C, like the set of centers should be less than K. If you have selected like as suppose 4, so that should not be run with that 4. Clear? What you have to do, it should be less than k, then only it will be having a proper solution for you. Clear? Next, what you have to do, there are just certain changes here, you can find it out. With the selected site which you have done, we have to maximize we have to find out whether that maximize the distance or not. Like here we found out like it is a different conditions, we found like f is a distance, more distance, so that's why we covered until which we thought as 2r. Based on that, radius is uniformly being there, that you have already read in mathematics. Here, as per the diagram, it might not be like looking like 2R, but 2R will be uniform throughout. So whenever you found uniform, might be one or two is getting outside of it. So we have to fix the maximum size first. Then based on that, we will be putting up a circle. So through that, at least we will cover everything. This is what we have added. We have merged. Clear. So site C to S means we have to add that C whichever we have already selected, that we will be adding with the C. Then at the end, what we have to do, we have to print or return, you can say, all the C means all the centered which was selected earlier, that we have to return it. This is what our modified algorithm, through which exactly it is also written, like what the peculiar thing we found in the previous greedy approach. Here it is said earlier greedy algorithm, which is armed with the knowledge R, like the value you should know. But repeatedly, what we have to do is at least two are away from all the previous selected nodes that we have done earlier. But this time, what exactly we have to do, like far from, we have to taken like the previous which we have selected, without knowing that at least two are away. Means we have to select not within 2R, we have to select more than 2R. This is what it is written. So means we will cover a maximum range through which at least we will say the centers are to be using the greedy approach. Okay. So one of the theorem is there. Whenever I have seen the content, I found this has the theorem, and one of them I found like Tados PDF, which is a course PDF. I found they have written instead of theorem as lemma. Okay, as we have already discussed what is lemma, what is theorem in the previous video for the load balancing, that you can check that one. What is said as to be lemma, what is said as to be theorem, that will be clarify your doubt. But let us take these are theorem. Okay, for the theorem, how do we prove it? Okay, it says RC means the radius of the which we got as C means the set of centers which we found is two times, okay, less than equal to the optimal one. The optimal is represented as C star. The optimal centers which is getting selected, the radius is two times, basically two times more than the radius which you have found out for the centers. Okay, so by the contradictions, once you start proving it, so assume R C star is less than half of RC, means that exactly the two which we have said, we just go this side we have represented as 1 by 2. Clear, this portion is completed. Next, as for the example which we kept are like C star represents the set of optimal centers, and this represents the number of sites. Clear. Next, for each site Ci in C, consider these are certain range or coverage as said to be balls here, but you can say it's a coverage. Okay, radius which we found as half of this RC. Clear, means this is half radius we are just keeping. Next, exactly one C star we found in this one. Here we found out C1 star, which is optimal for the timing. We said it's an optimal one, optimal center which we found. Let Ci be the site paired with Ci star. Clear, means we whenever we said like within the center we found it as a new optimal one, we said it's a lesser site paired. Okay, next consider any site. Here is S is considered here, any site nearby it. So which one, like how to then find the distance? So it's closest to center Ci in C star. So it is basically closest to this one. Whenever we are finding out the distance from the S which is source one which you have selected with a set of centers which you have already fixed. This is one set of center. This is one set of C, capital C, capital C. Clear. And the blue basically represents, this is one of the C star, means one of the optimal you can center we found in between this. Clear? So whenever we found it out, so as per the triangle inequality, if you want to find it, the triangle inequality said the distance between this S to this is represented as, this one is represented as the distance S with CI. Clear? Next, to find it out, the as per the triangle inequality, we should know the triangle inequality. This side is distance S with CI star. This represent distance C1 star with CI star with CI. This is what a triangle inequality. What you have to find it out. As for the triangle inequality, this condition follows. So this one, we can say it is less than the optimal one. Why? Because the CI star is closest to it. That's why we say it is uh, you know R of C star. Clear? And though inequality follows here also, this one which we found, it is also less than this R star. That's why when you add it, when you add RC star plus RC star, it gives you the result of 2RC star. This means it is which type of approximation? Simple, it is 2 approximation. Okay, so our result is giving 2 times more than the optimal one. But our main target is to get one approximation. One approximation is equivalent to optimal, though we are not getting it. So epsilon 1 plus epsilon that we have discussed, epsilon is 1. This is a proof basically whenever the question is there like whether two approximation we are finding out whenever the selection of center, whether it is two approximation or not. So this is what the proof is. Clear? Or else if it is said to be like RC is less than equal to 2 RC star means 2 times more than or not. So this is also the same way to give the proper explanation about two approximation. I hope it is clearly understood by you. If any doubt, comment below. Thank you and have a good day.